When you conduct research about a group of people, it's rarely possible to collect data from every person in that group. Instead, you select a sample. The sample is the group of individuals who will actually participate in the research. There is a need for you to understand the difference between a population and a sample and identify the target population of your research. The population is the entire group that you want to draw conclusions about. On the other hand, the sample is the specific group of individuals that you will collect data from. The population can be defined in terms of geographical location, age, income, and many other characteristics. It can be very broad or quite narrow. Maybe you want to make inferences about the whole adult population of your country. Maybe your research focuses on customers of a certain company, patients with a specific health condition, or students in a single school. It is important to carefully define your target population according to the purpose and practicalities of your project. If the population is very large, demographically mixed, and geographically dispersed, it might be difficult to gain access to a representative sample. We have this term sampling frame. The sampling frame is the actual list of individuals that the sample will be drawn from. Ideally, it should include the entire target population. For example, if you are doing research on working conditions at company X, your population is all 1,000 employees of the company. So your sampling frame is the company's human resource database, which lists the names and contact details of every employee. The number of individuals in your sample depends on the size of the population and how precisely you want the results to represent the population as a whole. You can use a sample size calculator to determine how big your sample should be. In general, the larger the sample size, the more accurately and confidently you can make inferences about the whole population. Probability sampling means that every member of the population has a chance of being selected. It is mainly used in quantitative research. If you want to produce results that are representative of the whole population, you need to use a probability sampling technique. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on chance. For example, you want to select a simple random sample of 100 employees of company X. You assign a number to every employee in the company database from 1 to 1,000 and use a random number generator to select 100 numbers. In systematic sampling, this is similar to simple random sampling, but it is usually slightly easier to conduct. Every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. For example, all employees of the company are listed in alphabetical order. From the first 10 numbers, you randomly select a starting point, for example, number 6. From number 6 onwards, every 10th person on the list is selected. These are, for example, 6, 16, 26, 36, and so on. And you end up with a sample of 100 people. If you use this technique, it is important to make sure that there is no hidden pattern in the list that might skew the sample. For example, if the HR database groups employees by team and team members are listed in order of seniority, there is a risk that your interval might skip over people in junior roles, resulting in a sample that is skewed towards senior employees. In this type of sampling, the stratified sampling, here there is an involvement of dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. To use this sampling method, you divide the population into subgroups called strata. This is based on the relevant characteristics such as gender, age range, income bracket, or job role. Based on the overall proportions of the population, you calculate how many people should be sampled from each subgroup. Then you use random or systematic sampling to select a sample from each subgroup. For example, the company has 800 female employees and 200 male employees. You want to ensure that the sample reflects the gender balance of the company. So you sort the population into two strata based on gender. Then you use random sampling on each group, selecting 80 women and 20 men, which gives you a representative sample of 100 people. We also have cluster sampling. Here, this involves in dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. If it is practically possible, you might include every individual from each sampled cluster. If the clusters themselves are large, you can also sample individuals from within each cluster using one of the techniques above. This method is good for dealing with large and dispersed populations, but there is more risk of error in the sample, as there could be substantial differences between clusters. It's difficult to guarantee that the sampled clusters are really representative of the whole population. For example, the company has offices in 10 cities across the country, all with roughly the same number of employees in similar roles. You don't have the capacity to travel to every office to collect your data, so you use random sampling to select 3 offices. These are your clusters. In a non-probability sample, individuals are selected based on non-random criteria, and not every individual has a chance of being included. This type of sample is easier and cheaper to access, but it has a higher risk of sampling bias, and you can't use it to make valid statistical inferences about the whole population. These sampling techniques are often appropriate for exploratory and qualitative research. In these types of research, the aim is not to test a hypothesis about a broad population, but to develop an initial understanding of a small or under-researched population. A convenience sample simply includes the individuals who happen to be most accessible to the researcher. This is an easy and inexpensive way to gather initial data, but there is no way to tell if the sample is representative of the population, so it can't produce generalizable results. Example, you are researching opinions about student support services in your university. So after each of your classes, you ask your fellow students to complete a survey on the topic. This is a convenient way to gather data. But as you only surveyed students taking the same classes as you and at the same level, the sample is not representative of all the students at your university. Quota sampling is a non-probability sampling technique wherein the assembled sample has the same proportions of individuals as the entire population. This is with respect to known characteristics, traits, or focused phenomenon. In addition, the researcher must make sure that the composition of the final sample to be used in the study meets the research quota criteria. The first step in this sampling technique is to divide the population into exclusive subgroups. Then, the researcher must identify the proportions of these subgroups in the population. Finally, the researcher selects subjects from the various subgroups while taking into consideration the proportions noted in the previous step. The final step ensures that the sample is representative of the entire population. It also allows the researcher to study traits and characteristics that are noted for each subgroup. This type of sampling involves the researcher using their judgment to select a sample that is most useful to the purposes of the research. It is often used in qualitative research, where the researcher wants to gain detailed knowledge about a specific phenomenon rather than make statistical inferences. An effective purposive sample must have clear criteria and rationale for inclusion. Example, you want to know more about the opinions and experiences of disabled students at your school, so you purposefully select a number of students with different support needs in order to gather a varied range of data on their experiences with student services. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. The number of people you have access to snowballs as you get in contact with more people. Example, you are researching experiences of homelessness in your barangay. Since there is no list of all homeless people in your barangay, probability sampling isn't possible. You meet one person who agrees to participate in the research, and she or he puts you in contact with other homeless people that she knows or he knows in that particular area.